Welcome back everybody to Professor Seemo. This is our first video on data structures. We'll first start talking about queues, nodes, since we'll be making a queue using nodes, node-based queues. Let's get into the video. Hope you enjoy this video. Hit the like, share button if you want more to learn and if you want more content. Okay, let's begin. Alright, so first we can start with queues. Queues, basically, actually, we all know what queues are, so it won't be of a problem when you go, for example, to uh, like to a roller coaster. You stand in the queue, for example. So let's say here's our line. You come from here. Let's say this is you. You stand in the front. Then the other guy and the third person. So as you can see, the first one that entered is the first one to leave, and this is called a FIFO structure: first in, first out. And as you can see, when a new person comes, he joins from the back. So we are adding from the back, and we are removing from the front. This is basically how this is how queues work. We can implement this using arrays or nodes. So what are nodes, right? Let's talk about nodes for now. Okay, as you can see, a FIFO structure for the queues. Alright, now I'm here in the Java project. Go to the source, right click, create. We'll start with an interface. An interface in Java is basically just a place, for example, you could just store your functions over there. There are many reasons for it. Don't worry about why we are going to use an interface. You can just create your interface. Let's call our interface queue. Alright. Okay, yeah. Okay. For queues, the part, if you remember, where the first person goes out of the queue, this is called dequeuing. Dequeue. Okay. And the part where there is a new person coming to the queue, this is called enqueuing. So for now we have two main functions, enqueue and dequeue, and we'll create some third function that returns the size of the queue, which is the number of nodes in the queue. Alright, so public, we'll make it return an integer. Our queue will be returning an integer. We can make it generic. We can leave that for another video. Maybe the next part of this video is going to be generic queues. Alright, let's call it public, returns an integer, enqueue. Enqueuing takes an integer item. Oops, sorry about that. Okay, integer item, and public. Oh, sorry. Enqueuing doesn't return anything, so just void. For dequeue, it will return the removed item. You've seen the first guy to go out of the queue is the one who is going to be returned. Alright. Public and dequeue, it doesn't take any parameters or arguments. Then we have the public and size, which returns the size of the queue. Alright, now let's create another file. We'll create a class. Let's call it node. Here, node queue. Here's our node. Okay, we're not going to as we have seen before, our nodes have a value and a next pointer. Let's first start with the next. The next is going to be a node type of node queue. Node queue next. Alright, and we have another one of type integer, since our nodes are going to store integers, private integer, let's call it item or value, anything. Okay, now for the constructor, node q, the constructor is going to take an int item value and we'll set next to null. Alright, item this dot next equal null. Alright, now we'll set setters and getters. Actually, let's first set the setter and getter for the next. Okay, for the value of each node we don't want it to change, so basically just say private final means once you give it a value you can change it, but let's give it a getter. Okay, this is our node class. Now let's go to the interesting part, which is the Q class, and implements Q. Alright, it's giving me an error because I have to implement the functions from the Q class, Q interface. So let's just use implement methods. So here, as you can see, our first Q, enqueue, dequeue, and size. Let's start with size, or let's first start with the queue itself. Okay, we have seen that first we have a queue. The queue itself has pointers, so we have the first pointer to be of type node queue, pointing at the first pointer, first private node queue of type last, and private int n for the size. Alright, let's just move this. Okay, now for the constructor, public queue for the constructor, set first equal to null, last equal to null, and n is equal to 0. Let's now go to enqueue. Okay, for enqueue, first we have to check, is our queue empty? Is our queue empty? If, where am I? Okay, if our queue is empty, we can, this could be demonstrated using multiple ways. I will go with first is equal to null. If first is equal to null, give it the item value. So first equal new node, let's give it a value item. Then last is equal to first. We'll make first last point at first. So first and last are going to be pointing at the same node. Alright. Okay. This is let's here the comment if the queue is empty. Alright. Alright, if it's not empty, what should we do? We will else, actually without the else. Okay. Else. Okay. By the way, we'll be increasing n, just in case we don't forget that. Let's put it at the end. Okay, let's go back to Paint to help us visualize what's going on till now. Okay, back to the code. Sorry, back to the Paint. So what we have done till now is basically just if the queue is empty, now we will enqueue to this empty node. We have given it a value of item and a next, which is null, sorry, and here first and last are pointing to it, to this first node, first and last actually. Then what if it's not empty? Or no, what happens when we want to enqueue another second item? How we are going to do it? Let's change the color. We have this other node with its own item and another next. So what we'll do is we'll create a node, a queue node. We'll call it odd last. Okay, equal to last. Then use this one to change the pointer itself of last. So it could be this equal to this next node, and we will also use it to make this next node equal to this node. You will see that in the code. Let's go back to the coding section. Or actually, before going there, let me re-explain it real quick. Starting with the new port where there are multiple nodes being enqueued. Okay, so we'll create this node, call it odd last. Okay, set it equal to the last item. Now create the new node, this one, the new node. We create last equal a new node. Okay, then since this odd last is equal to the odd last, we'll use this odd last dot set next. Okay, you see what's going on? First, we it's like storing the pointer of the old node in an old last. Okay, we have, as we said, we have pointers, right? This last pointer stored in some other place. We'll call it old last. Okay, now create your new node and give it the last pointer, you could say. Okay, now it's called it's just a new node with a null next. Then use that old last, which is pointing at the old last, make it set next to the new last. See, it's not that hard. Let's get into the code for it now. All right. Okay, as you have seen before, here's our queue. Else, if it's not full, then just node queue old last equal to here we call it last. Then create your new last, which is last equal new node queue. Give it the value of the item. Then, as we have said, old last dot set next to last and increase n plus plus. All right. Now let's go to the dequeue function. Dequeue isn't that hard either. We'll discuss it in the paint also. All right. Now for dequeue. First, if there is nothing, just return null. Okay. Now if we have one node with a value of item and a next pointer, here keep in mind if we have one item, our next is pointing at null, okay, since we have one item. And at the same time, this function dequeue, it's going to return the value of the item of this node. Alright, so we will store it somewhere else because we will store it in a temporary variable. Temporary. Okay, but what if we have multiple nodes, right? So what's going to happen is we are going to set first to the next item. So we'll use get next, basically get the next item. Sorry, get the next node and return temp. Also, we are going to check if get next, as we have seen here, get next, if it is null, then now we have an empty queue, and we will set first equal to null. It's already going to be set to null, and we will set back to null. Let's not forget about back. Okay, now they will both become null, and before returning the temporary variable, let's decrease n minus minus to stay within the right size. All right, let's get into the coding part. All right, back to the coding part. Let's first create our temporary variable, which has the value of first dot get item. Then we'll set first is equal to first dot get next. First, let's check if the queue is empty. How could we check if the queue is empty? We can use the fn equal 0, just return null. All right, it's not that oh sorry, fn equals 0. Since we should return an integer, we'll be using null and these types in the generic node queue. All right, let's see. You can just return -1, for example. Let's return temp over here. Let's not forget to decrease n. Okay, here. Then first equal to get next, and if first is now equal to null, set back equal to null 2. Oh, sorry, we don't have back, we have last, the last thing in the queue. Hopefully that's everything. And size, we return null. So we will get the item, and first is equal to get next. If first is equal to null, set last to null 2, n minus minus, return temporary. Hopefully, I think you will be hope you enjoyed this video and learned from it. I'm going to create a new video. It's just going to be a quick video. We are just going to rewrite the code, but making it generic. All right. You'll probably see this code in my GitHub link. I'll probably leave it in the comment section. If not in this video, in the next one, just check the comment section if it's there or not. And hope you enjoyed this video, and if there are specific data structures that you want me to make, you can just drop a comment. Don't forget to like, share, and subscribe, and hope you enjoyed this video again and again and again. See you in the next video, but first let's test the code, or at least let's check if it is working properly, right? Yeah, that would be a good idea. Let's see. Alright, I have written some test codes. Let's create the test file. Let's call it node q test, and it's just okay. I have to delete some stuff because I have q test. Okay, let's keep the main function. Let's just remove this one, move this. Okay, and that's perfect. Let's run it. Right click, run your code. Okay, it's compiling, running. Okay, as you can see, 4911. Okay, this size we have 1, 2, 3, 4, 1, 4. Okay, DQ, 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 911. Okay, and the size at the end is 0. So let's recheck our DQ function. Q.DQ, Q.DQ, Q.DQ. It's supposed to return 911, 808, 333, 755. Okay, let's recheck the code together. Alright guys, back to the code. Let's see. Okay, I have checked this okay, and I noticed something. First, let's go to enqueue. Here, let's write an else statement. Okay, and in the DQ, okay, let's try running the test function. 911, 808, 333, 755. That's it. Yeah, but also I want to try something here in the DQ. If n is equal to 0, let's try doing first will get item. We're going to do is anything. 755, 333, 828, 911. If you have different ideas of how you could implement this, as now you understand how NodeQ works, queues in general, you can share that with us, send me an email, everything is in the description. Thanks for watching, and if you have reached this part of the video, that's I'm really thankful for that, and we'll see you in the next video.